The JUMO IPC IGBT power converter is an innovative solution regarding energy cost minimizing, process security, and energy efficiency. This video shows the functions and the benefits of the JUMO IPC IGBT power converter. The IGBT power converter, as well as the Thyristor unit, are used for electric heaters with higher standards concerning the quality of control. To feature the advantages of the IGBT power converter, first of all, we would like to describe the functionality of a Thyristor unit. The main differences between the systems arise from the operating modes. A Thyristor unit can be used in the so-called burst firing operation. The diagram shows the supply voltage. In case of burst firing operation, only a part of the supply voltage full waves are switched on the load. If the controller requires, for example, an output of 60%, 3 supply voltage full waves will be switched on the heater and 2 full waves are inhibited. Switch on and switch off is always affected at the zero crossing point. A disadvantage is the voltage fluctuation on the power line. This happens when the supply feed does not have a sufficiently low impedance. This effect, known as voltage flicker, causes unpleasant variations in the light intensity of any lighting installation that are fed from the same supply. Otherwise, this operation is unproblematic. Furthermore, phase angle control is possible. Here, the Thyristor unit switches a part of the supply voltage half waves on the load. The phase angle varies according to the required power. The bigger the phase angle, the later the Thyristor is switched on, and the less energy is transferred to the heating system. In the example, the phase angle is 45 degrees. In the phase angle control, the Thyristor unit generates the smallest energy packages. That means switch on and switch off is executed more often than during burst firing operation. Therefore, you can realize the high quality of control even with very fast control processes. But 2 disadvantages arise, which we will explain in this video. The Thyristor are not switched in the zero crossing point. Because of this fact, there is a big EMC error potential. The Thyristor unit in phase angle control generates reactive power in the event of a control angle bigger than 0 degrees. The example shows the supply voltage. In the event of a phase angle of 90 degrees, the load voltage runs as follows. Due to the ohmic load, the load current characteristics is qualitatively the same as the load voltage. The load current complies with the mains current. Although an ohmic load is used, the 50 Hz part of the mains current follows the supply voltage. Reactive power results. The proportion of the reactive power increases when the phase angle is increased. To keep the reactive power within a limit, compensation plans are often necessary. The picture shows the general connection of a Thyristor unit in a single-phase system. The control electronics requires a power supply. In the example, the output of the controller is given as 4 to 20 milliamps. Regarding the load circuit, the phase is switched on the load via the thyristors. For dimensioning of a thyristor unit, two values are necessary: the load current and the load voltage. The chart shows the possibilities. The power supply for the control electronics of JUMO thyristor units is a nominal load voltage. That means an additional power supply for the control electronics is not necessary. A thyristor unit has a favorable cost-performance ratio and can be used for many applications. But both operating modes have disadvantages like EMC error potential and reactive power during phase angle control, or the low quality of control and the flicker effect during burst firing operation. Now we would like to show you the patented JUMO IGBT power converter IPC. This device allows for operation without the mentioned disadvantages. The power converter has one operating mode, the amplitude control. The picture shows the supply voltage, load voltage and load current during operating of the power converter. Load current and load voltage are pulsed. The rates of the amplitudes are changed according to the required power. The resulting mains current has the same phasing like the supply voltage. In contrast to the thyristor unit, during phase angle operating, reactive power does not exist. The continuous mains current shows that there is no flicker effect like during burst firing operation. We are looking at the load current and the mains current during operation. The IPC supplies electrical heater. The power converter is operated via a controller on manual mode. An oscilloscope shows load current and mains current. The required output is 50%. When the output is increased to 100%, the amplitudes of load current and mains current are increased as well. Now we would like to show the functionality of the power converter. The supply voltage is rectified in an intercircuit. The IGBT is drawn as a switch and is switched on and switched off with a frequency of 16 kHz. Due to a pulse width modulation, the pulse DC voltage is generated on the load. Due to the shown inductance, the load current and consequently the load voltage rises after switched on with a delay. During switch off, the load current flows on the catch diode and falls delayed due to the inductance. Without inductance, the power converter does not work. Now we would like to inform you in general about the electrical connection of the power converter. The power supply for the control electronics is switched on the power converter via an EMC filter. The EMC error potential of the power converter is much lower than the error potential of a thyristor unit in phase angle control. Nevertheless, you need an EMC filter for the load circuit. This filter is part of the accessories which we charge separately. The voltage for the load circuit has to be connected. Due to the connection of load and choke, they are connected in series. The shown connection of the controller applies to a signal of 0 to 10 volt. This usually corresponds to a signal of 0 to 100%. The IPC with corresponding choke is available for load current 70, 100 and 200 amp. The load voltage is available in different versions up to 380 volt. EMC filter for current up to 100 amp can be used. The load current of IGBT power converter results from the nominal power of the heaters divided by the load voltage. For dimensioning the supply line and the EMC filter, you have to keep in mind that the mains current results from the nominal power of the heater divided by the mains voltage. The picture shows an example how to install a 200 amp power converter with a 200 amp choke and the 100 amp EMC filter. In addition to the advantages described before, we would like to inform you about further advantages of the IGBT power converter IPC. Simplified, you can see a Thyristor unit as a fast switch. Depending on whether the switch is opened or closed, the Thyristor unit alternates between 0 and the maximum output. If, for example, the required power is 15 kilowatt and the nominal power of the heater is 30 kilowatt, the Thyristor unit will alternate between 0 and 30 kilowatt. Our example shows a plant with 3 of these systems. Even if only 3 times 15 kilowatt, so 45 kilowatt are used, sometimes the Thyristor units switch at the same time. Then the peak load is 90 kilowatt. This results in a higher connected power and causes higher costs for the plant owner. When using the IGBT power converter IPC, the situation is different. Every system continuously requires 15 kilowatt, and this corresponds to the peak load. The peak load is 45 kilowatt instead of 90 kilowatt when using the Thyristor units. When using the power converter, the connected power is reduced to the actually required active power. The Thyristor unit alternately switches the power on or off. During switch on, the temperature of the heaters rises. During switch off, the temperature of the heaters falls. This stresses the heaters. A IGBT power converter causes a constant temperature of the heaters when the required power is unchanged. Furthermore, the maximum temperature of the heaters is much lower than the heater temperature when using a Thyristor unit. The mentioned facts improve the running life of the heaters, possibly enormous. Our customer realized a noticeable longer running life, for example with the following applications: insulated heaters for smelter application, silicon carbide heaters for continuous furnaces, molybdenum heaters for drying application. When using low voltage heaters, a transformer is necessary for conventional applications. Due to the amplitude control, the IPC has the same function as an electronic transformer and generates a pulse DC voltage. An external transformer is not necessary, so you have no procurement and logistic costs. A very high heater temperature reduces the running life of the heaters or can even destroy the heaters. The power converter can measure the temperature via the element resistance and reduces the power output when the maximum temperature has reached. The heaters are not stressed by very high temperatures and consequently they are not destroyed. The resistance of SiC elements rises during the running life. Consequently, when the voltage remains stable, the power and the temperature of the heaters are reduced. You have to increase the load voltage to generate the same power. To increase the power, you have to use a transformer with several voltage tappers for the thyristor unit. When the voltage of the transformer is no longer sufficient, you have to manually select the next higher tapper. This causes a voltage jump which stresses the heater. Due to the integrated voltage reserve and the amplitude control of the IPC power converter, the voltage is automatically corrected. A manual change is not necessary.